Hello students, in this video we are going to solve a numerical example based on a special case of direct central impact, that is impact with a body of very large or infinite mass, right? So let us read the statement. A ball is dropped from a height of 1600 millimeters and is observed to rebound to the height of 1100 millimeters from the horizontal floor. Determine the coefficient of restitution and the percentage of mechanical energy lost during the impact. Here the ball is dropped on the floor. So the velocity of the floor before and after impact with the ball is 0. So that is a special case, right? Here there is an impact between the ball and the floor, but the velocity of the floor before and after impact is 0. So first we will derive a general formula. Then you can put these values in that formula to get the required answer, right? So let this ball is dropped on the floor from a height say h1. Then the ball will strike the floor with velocity u1 and then it rebounds to a height say h2. So before impact, the direction of velocity of ball u1 is downwards, and after impact it will move upwards, say velocity v1. So h1 is the height from where the ball is dropped, h2 is the height of rebounds after impact. So initially when the ball is dropped from this position, so here the velocity of the ball is 0, right? It is dropped from rest. So this ball will possess potential energy at this position. So when the ball strikes the floor, just before it strikes the floor, so the ball will possess kinetic energy. So this entire potential energy is converted into kinetic energy. So assuming the no loss between these two positions, we can equate the potential energy is equal to kinetic energy as per principle of energy, principle of conservation of energy. The total energy remains constant. The total energy means here we are referring to the total mechanical energy, that is potential energy and kinetic energy. So at this position potential energy is there, kinetic energy is 0. So just before it strikes the ball we will have kinetic energy and the potential energy is 0, right? So we are equating the total energy at both the positions, so neglecting the loss. So the potential energy is mg h1, h1 is the height, is equal to the kinetic energy half m u1 square. u1 is the velocity of ball before impact. So here I am considering ball as body 1, floor is body 2. So the velocity of the floor before and after impact, that is u2, v2, both are 0, right? So from this you get u1 is equal to root 2g h1. But remember this u1, velocity of ball before impact, is downwards. So as per our sign convention we consider downward velocities are negative. So u1 is equal to minus root 2g h1, right? Now after impact, immediately after impact, this ball will possess kinetic energy here. After reaching the height h2, that is converted into potential energy. Again, equating kinetic energy and potential energy after impact, we have the kinetic energy is half m v1 square, right? v1 is the velocity after impact, is equal to potential energy is mg. Now h is h2. It rises to height h2. So here you get v1 as root 2g h2. But before impact velocity is downwards, so it is negative. After impact velocity is positive, so it is upwards. Right. Now, what is the formula for coefficient of restitution? Coefficient of restitution is given by v2 minus v1 upon u1 minus u2. Here, for impact with a body of very large mass, v2 is 0 and u2 is 0. So coefficient of restitution is minus v1 upon u1, right? So E is equal to minus, what is v1? v1 is equal to root 2g h2, square root of 2g h2 upon u1. u1 is minus root 2g h1. Is clear? So finally, the coefficient of restitution E is equal to square root of h2 upon h1. So this is the formula for coefficient of restitution for impact with a body of large mass. When a ball is dropped from a certain height and after impact the ball rebounds to a certain height. So before impact it is dropped from the height h1. After impact it rebounds to height h2. So knowing h1, h2, we can find out the coefficient of restitution. So in our example, it is said that ball is dropped from a height 1600 millimeters. So h1, the height of drop is 1600 millimeters. And it is observed to rebound to the height of 1100 millimeters. So h2, the height of rebounds, is 1100 millimeters. So putting these values, you have E is equal to square root of 1100 upon 1600. That gives you 0.829. That is our answer. The coefficient of restitution. Right? So if you remember this formula, simply you can put the values h1, h2 to get the coefficient of restitution. Now let us derive the formula for the percentage mechanical energy lost during the impact. Here, mechanical energy means it is potential energy and kinetic energy. But at this position where the impact is taking place, the ball will have only kinetic energy. Right? This h1, h2 are referred with respect to the datum, with respect to this position. So the potential energy of the ball at this position will be 0. So when you are talking about the percentage of mechanical energy lost, means it is the percentage of kinetic energy lost, being potential energy is 0. Right? So the percentage of kinetic energy lost is equal to the kinetic energy before impact minus the kinetic energy after impact upon initial kinetic energy, that is before impact, into 100. So the kinetic energy before impact minus kinetic energy after impact, that will be the loss of kinetic energy, upon initial kinetic energy into 100, that is percentage loss. So this is equal to, what is the kinetic energy before impact? So before impact the velocity of the ball is u1. So the kinetic energy is half m u1 square minus the kinetic energy after impact. After impact the velocity is v1. So it is half mv1 square upon kinetic energy before impact half mu1 square into 100. So simplifying this, this is equal to, you can take half m common and cancel. So we have u1 square minus v1 square upon u1 square into 100. What is u1? Root 2gh1. So u1 square, that means it is 2gh1 minus v1 root 2gh2, v1 square. So it is 2gh2 upon u1 square 2gh1 into 100. Again taking 2g common and cancels, you can have h1 minus h2 upon h1 into 100. So this is the formula for percentage of energy loss. So now simply you have to put the values to calculate the percentage loss. So here what is h1? H1 is the height of drop, 1600 millimeters, minus h2 is height of rebounds, 1100 millimeters, upon 1600 into 100. That will be 31.25%. So it is the percentage loss of mechanical energy because of impact. So here you have to remember two formulas. One is coefficient of restitution is equal to square root of h2 upon h1. Then percentage of energy lost is equal to h1 minus h2 upon h1 into 100. Understood? Thank you.